Hi everyone, can you hear me okay? Yeah. Great. Good morning. It's really good to see so many people here today instead of actually on a screen, which is all I've ever really known while I've been at Cloud Know-How. I'm Stuart Jenkins. I'm an Azure Solutions Architect with Cloud Know-How. So we are the services arm of our group of companies with Grey Matter. So I'm here to talk to you about IoT this morning. Still some people coming in. So just in terms of my background, I've been working in IT for about 20 years. Probably many of those years sort of in project and support roles with medium and small companies, and then followed by 5 years as an IT infrastructure lead in the public sector, and then the last 2.5 years with Cloud Know-How, so specialising purely on Azure. So for the last 2.5 years. Before moving to Azure, my background was very much on-prem, Windows, Linux, virtualization, networking, etc. But I now focus purely on Azure. I'm a certified Azure Solutions Architect and a certified Azure IoT developer. So the session that we're going to run through, we're going to discuss the fundamentals of IoT on Azure. I'll be covering areas such as device selection, enrolment, security, edge computing considerations, bear with me, and cloud services such as IoT Hub and IoT Central. I've got a number of demos to run through, and we'll have some time for questions at the end as well. So really this session's designed as like a 1,000-foot overview of Azure's offering in the IoT space, really just to give you a taste of what is possible. So let's crack on really. So what is Internet of Things, or IoT? So IoT itself describes physical objects with sensors, processing power, and other technologies feeding telemetry and state changes and alerts into like a centralized command and control and reporting system, if you like, to gain insights from our data. It could be a consumer system, such as a smart home, central heating controls or connected light bulbs, or it could be an industrial system, a connected building, factory, vehicle tracking. We could be monitoring a production line for issues, allowing us to perform preventative maintenance or tracking a vehicle or asset location. But really, IoT is all about data, gathering data, getting insights from our data. Microsoft like to talk about the intelligent edge and the intelligent cloud. And in IoT, this represents what we do in creating solutions across two disparate worlds, bringing them together in a secure manner. Taking Azure's IoT services, edge computing, maybe artificial intelligence, machine learning, digital twins, to really extract insights and value from our data. So, looking at the slide there, the things are the machines you're connecting to, the devices you're using to connect to them, and the hybrid or the edge compute that you have. The gateway to the cloud is typically a platform service called IoT Hub, or we have an application platform service called IoT Central. This provides the device management capabilities and securely accepts data from the device. Moving into the insights, we often talk about Lambda architecture and different paths of data, and that's super relevant for IoT because we do typically want to treat different types of data differently. And often there is more than one type of data store in an IoT solution. And then finally, the actions, what we want to do with that data. So integrating with back-end systems, visualizing the data with the dashboard, etc. One thing to bear in mind, which is an important point I think, is that all of that can be achieved using native Azure platform services without a single virtual machine in there. So there's no virtual machines in Azure for you to patch and maintain. Some of the insights workloads can be run on the edge, they can be moved to the edge, and that does require you to maintain compute there. Slightly different sort of use case to maintaining compute in the cloud, but we'll start to take a look at the edge and see what you can do in that area. So I always like to talk about the edge in IoT terms as being a spectrum in terms of computing power. So, for example, on the left-hand side, we've got a very basic, non-intelligent temperature sensor. It cannot really do anything itself apart from measure temperature and send its output. It probably costs a few pence, and it sends readings over a low power sort of wireless network such as Bluetooth or LoRaWAN, and that will probably need to connect to some kind of compute platform or a gateway on the edge to process that data and send it up to the cloud. So as we start to move over towards the right, we get into low-cost simple devices. So that could be a microcontroller-based device with a simple CPU, maybe costing a couple of pounds. They could be deployed running Azure RTOS, which is Azure's real-time operating system. But providing they've got sufficient power to run a TLS stack and an MQTT stack, they can connect directly to the Azure cloud. So that's an example there of a simple device. It's a dev kit from Microsoft. It's running an ARM M4 core with 256 kilobytes of RAM, 2 megabytes of flash and Wi-Fi. That's sufficient to run the TLS and MQTT stacks. That's currently sat at home on my windowsill connected to my home Wi-Fi. So it's feeding telemetry into a system that we will have a look at shortly. But back to that edge spectrum slide. The next device along, which is that one, that's an Azure Sphere device. It's another dev kit from Microsoft. It has more compute power, but it also has a great deal of security built into it, so it's considered a highly secure platform. The next device along is a basic compute board, so it's a Raspberry Pi. The next device after that is actually this device here. So this is it's a vision edge processing, and it can be an audio edge processing development kit, again from Microsoft. It's called the Azure Percept. So it's running an Intel VPU, and it can perform those edge artificial intelligence workloads. So it can run those workloads on the edge. So that's what I demoed earlier, and we'll have a closer look at that as we sort of go through. And then we get into perhaps sort of more traditional forms of compute in terms of desktop PCs and industrial gateways and server hardware. So Microsoft have specific offers that can run on that hardware. So if you have a requirement for a lot of compute on the edge, you could run something like Azure Stack Hub, which gives you your own Azure cloud in your own data center and gives you, that Azure functionality and experience, but in your own data center. In terms of software offerings from Microsoft, I mentioned Azure RTOS, or Real-Time Operating System for Embedded Systems. So it's an embedded development suite, which includes a small but really quite powerful operating system that provides ultra-reliable, ultra-fast performance for embedded devices, resource-constrained devices. It's really easy to use. It's market-proven as well, and it's been deployed on more than 10 billion devices worldwide so far, and supports most of the most popular microcontrollers. And then in terms of sort of the software for the edge, Microsoft have IoT SDKs to ease the development of these for .NET, Python, Node.js, Java, and C. When it comes to the edge in IoT, we really need to consider security from the start, because you can potentially have millions of devices out there in insecure locations sending data into the cloud. And if any of these get compromised, your entire solution could be at risk. So keeping your IoT solution secure really is the best way to ensure that you can rely on your data and your connected equipment. So I'll talk about the 7 properties of highly secure devices, which is something that Microsoft have come up with, and really where Microsoft came from when creating the Azure Sphere MCU, which is the highly secure MCU I mentioned. A lot of the work came about from creating that actually came from the work they did in developing Xbox. So the first incarnation of Microsoft's Xbox had 2 of these properties, one of which was the hardware root of trust to prove its identity, or the Pluton security subsystem, as they like to term it. The second generation, Xbox 360, had another 1 or 2 of these properties, and finally Xbox One had all 7 of these properties. There's a link at the bottom. I can share it out if people want it as well. It's a really good white paper, which I would encourage you to read if this is an area that is important to you or you're interested in. It really explains in depth all the different aspects that Microsoft say you need to have if you're going to have a device that's out there in the wild. Microsoft state really you need to have all of these 7 properties to be able to consider a device secure. So the Azure Sphere MCU has all of these properties. And so what we have out there really is a device that can connect securely, and it can send its telemetry, it can send its data, and it can receive commands, it can receive software updates from the cloud as well. So the Azure Sphere solution itself is made up of 3 components. There's the MCU, which I've mentioned. So you can either get the dev kit with the MCU built in, or you can get the MCU and build it into your own solution. You get the in-depth defense, which is provided by the Sphere OS from Microsoft, and you get over-the-air updates from the Sphere Cloud Security Service as well. So this is something Starbucks have actually used. So they've leveraged Azure Sphere to securely connect their coffee machines up. So they can pull telemetry, they can do things like efficiency savings, maintenance, preventative maintenance through having their coffee machines securely connected to the Microsoft cloud. So we've touched on different hardware options potentially for Azure, and really, you can connect any device to the Azure cloud, to the Azure IoT services. But I also wanted to sort of discuss Azure Edge as a compute service as well. So I mentioned earlier that you can push workloads out from the cloud to the edge, and I'll just explain a bit more of what that means now. So, in the typical IoT scenario that we've discussed, we have our things, our insights and our actions. And our insights and actions are workloads that are running in the Azure cloud. IoT Hub is our gateway, and all that works fine. Data goes into the cloud, we can send commands back, and we can configure our things and our machines as appropriate. But that starts to become a problem where we don't have connectivity, or if we have, say, unreliable or expensive connectivity, and then that model starts to fall down. It also falls down as well if we have data which must not go into the public cloud. So in these scenarios, we want to be able to push workloads out from the cloud to the edge and run them close to our data. So really, our data never actually has to leave the device or the building perhaps it's in, and we just send the data we're allowed to send. We process the data on the edge, send perhaps just the telemetry up to the cloud, and we're reducing our risk there. So in the scenario here, which is really what I sort of demoed at the very start, we're doing some local video capture. We've got some code in the cloud to process that video, so that could be breaking it down into individual frames, carrying out the object recognition, which I showed at the start, or perhaps it could be a video feed of people viewing, say, like a digital billboard. You want to capture things like impressions and engagements of people who are viewing your adverts. So Azure has some out-of-the-box cognitive services you can use for that purpose. The one that's running on that device is an out-of-the-box one. I've not done anything with it, but you can train your own models as well. Perhaps you've got some custom code that you want to execute as well to carry out that transformation or that insight or that action workload. So the way Azure solves that problem of not sending that data to the cloud is to move those workloads to the devices, and that's with Azure IoT Edge. So Edge is made up of 3 components. So IoT Edge modules are, they're containers that run Azure services. They could be running containers that are running third-party services or your own code. These modules are deployed to the Azure Edge IoT devices, and they execute locally on those devices. Then we have the IoT Edge runtime that manages the modules that are deployed on each device. That is running on your device as well. And then we have a cloud interface that allows us to remotely monitor and manage all of our IoT Edge devices. So the modules, I can't say that word this morning, the IoT Edge modules are units of execution. They're implemented as standard Docker containers, which may be something you're already familiar with. You can have multiple modules configured to communicate with each other on an edge device, so you can build up a pipeline of data processing on the edge device. You can develop custom modules. You can package certain Azure services, such as Azure SQL or Azure Blob Storage, and actually run those services on your edge device. The Edge runtime pulls down a workload description, and then it will pull down the containers, and then it executes them locally, and it's processing everything you need without having any connectivity to the cloud apart from that initial setup. So that edge runtime can be deployed on both Windows and Linux-based devices. And finally, I think it's really important to note all of this is highly, highly scalable. It's designed for managing large fleets of millions of devices at scale. So in the example of the digital billboard, or the example that I showed at the start, we're not streaming that video to the cloud. Video is never leaving the device apart from for demo purposes on the local network. We're processing the video on the device using that workload, and we're just transmitting the telemetry up to the cloud. So we need, low power connection, maybe 4G, maybe just, we just send back telemetry up in batches, just up to the cloud as and when connectivity is available. So that's how we solve, complex problems around, running workloads on the edge, and we, maybe lack the connectivity to the cloud. So this is the Percept device, the Azure Percept device. It's a really easy to use development kit from Microsoft that powers real-time insights through hardware accelerators. It's integrated with AI and ML in Azure. It works out of the box with Azure Cognitive Services. I took it out of the box, connected to my Wi-Fi, connected it to Azure, and I was up and running within probably 30 minutes with that device. It's got an ARM Cortex-A53 core and an M4 core. This one's got 16 gigabytes of storage and 4 gigabytes of RAM, along with an 8 megapixel camera, so significantly more compute power than the other board I showed. It has an audio module that can be added on as well, which I don't have here, but that allows you to have AI-powered audio applications, such as something along the line of a smart home assistant. We have touched on the offerings on the edge. We've reviewed different hardware options, different sort of device security options and possibilities for running workloads on the edge. So we're now going to look at the offerings that Microsoft provide in the cloud. So in terms of the cloud, we've got a number of Azure platform services that we can stitch together to create a solution. The IoT hub can be combined with device provisioning services and digital twins with a number of different data stores, so large-scale data lakes, Azure SQL databases, Cosmos DB databases. We have an APaaS solution, or Application Platform as a Service, called IoT Central, which I will demo, but Microsoft described this as sort of Office 365 for IoT. Basically, once we get into the cloud, we have a huge number of options and different partner solutions. So it's really quite simple to get something working relatively quickly and maybe get you to a proof of value stage. So one important service just to note on here is Defender for IoT. So that provides continuous sort of monitoring for threats and vulnerabilities, along with IoT-aware behavioural analytics and threat intelligence. That's a bit of a mouthful. It's an optional service, additional cost, but it's one that I very much recommend if you're deploying an IoT solution, because it gives you that sort of assurance that your solution is secure. So we're going to spend a bit of time looking at IoT Hub, because this is really, it's the key platform service in Azure. Excuse me. It's a managed service. It acts as a central message hub for bidirectional communications between your application in the cloud and the devices that you're managing. You can use IoT Hub to build IoT solutions that have, really reliable and secure communications. And again, it scales to millions of devices. So it provides that connectivity between your devices and the cloud solution back end. And as I said earlier, you can connect virtually any compute device to Azure IoT Hub. It supports communications from both the device to the cloud and also to the cloud to the device as well. It supports multiple different messaging patterns. So we have device to cloud telemetry, file uploads, request-reply methods to control your devices from the cloud, and it also through monitoring. You can help you maintain the health of your solution, tracking events such as device creation, device failures, device connection events, things like that. So all of these capabilities really help you build scalable, fully featured IoT solutions, such as in managing industrial equipment, tracking valuable assets in healthcare, monitoring building usage, tracking vehicles, etc. IoT Hub provides that secure communication channel that I mentioned. Each IoT hub is something important to note, that each IoT hub has a globally unique DNS endpoint which is used for the device communication. So hub itself is providing sort of per device authentication to enable each device to connect securely and prove its identity. It provides complete control over device access, and you can control connections at the per device level. It automatically provisions, the IoT Hub provisioning service, device provisioning service, which is an add-on to IoT Hub, will automatically provision devices to the correct hub when they start up. And they support, like I said, there's multiple authentication methods you can use to authenticate your devices to the hub. It scales really, millions of connected devices and millions of events per second. So we'll have a look at how far this scales in a minute. When devices send the messages to the hub, they go into a queue, and then we connect other Azure services to that queue to pull them out. So that allows us to really build complete end-to-end solutions. So for example, you could use something like Azure Event Grid to enable your business to react quickly to events in a sort of a reliable, scalable manner. We can use Azure Logic Apps to automate your business processes. We can use Azure Machine Learning to add that ML and AI to your solution. And we can use Azure Stream Analytics to run sort of real-time analytic computations on the stream of data as it's coming in to our solution. IoT Hub provides lots of functionality for managing our devices at scale. So we can store and we can synchronize and we can query metadata about our devices and state information for all our devices at scale. We can set device state either like per device or on a common set of characteristics for your devices. And we can automatically respond to device reported state changes by having different message routes set up off the back of IoT Hub and the Lambda architecture to route our messages to the appropriate destination. In terms of billing for IoT Hub, something billing is always very important. It's billed on a per message basis. Each message from a billing perspective is up to 4 kilobytes. You can send larger messages, but they're billed as more than one message on 4, 8, 12, 16 kilobytes, etc. The smallest hub starts at 400,000 messages per day, and it scales up to 3 billion messages per day. And that's per hub as well. And we can deploy multiple hubs in multiple regions as our application requires. So it's a massive big data ingestion service. So I mentioned about provisioning devices, and that's where we have the device provisioning service or DPS from Azure. So it's an additional component of IoT Hub. It's an optional component, but it's one that I recommend, again, for any IoT solution because it actually provides full device lifecycle management. So if we talk about provisioning, it can mean different things depending on the industry that we're in. But in terms of IoT devices, it's about provisioning those devices to their cloud solution. And it's a two-part process, really.
On the commercial marketplace, from listing, free trials, bringing
That's not me.
through to transacting solutions through the marketplace itself.
Can you hear me okay?
Yeah.
Right. So as I was saying, provisioning IoT devices to their solution is a two-part process. The first part is establishing the initial connection between the device and the IoT solution by registering the device. And then the second part is applying a proper configuration to that device based on the specific requirements of your solution, or the specific requirements of the solution it's registered to. Once both of those steps have been completed, we can then say that a device has been fully provisioned. So the DPS, the device provisioning service, automates both steps to provide a seamless provisioning experience for your device and for your end users as well. In terms of authentication, attestation mechanisms, there are 3 that it supports. So Trusted Platform Module, or TPM, so having a secure hardware root of trust on your device, X509 certificates, and symmetric key. So I mentioned earlier that each IoT hub has a unique DNS endpoint for sending the data through. DPS actually provides a single global provisioning endpoint for all Azure IoT customers. So in terms of like the initial setup, once that DPS endpoint is baked into your devices, the initial setup, once a device goes out to one of your end users, it can be zero touch. Plug it in, switch it on, goes to the provisioning service, gets provisioned to your hub. The DPS can load balance devices across multiple hubs. It can support multi-tenancy in your environment, so connecting devices to their owner's IoT solution based on your device sales transactions. It supports geo-sharding, so it can connect a device to the IoT hub with the lowest latency. So you could have a hub in UK South, you can have a hub in North Europe. The device provisioning service will use latency to get your device connected to the most relevant hub. So in terms of billing for DPS, that's billed on a per operation basis. So for each provisioning operation, that's a billing. That's an operation from a billing perspective. In terms of device management, and this is again sticking with IoT Hub and its capabilities. I mentioned about device metadata. So that's held in what we call device twins, which are JSON documents that get replicated between the device and the cloud. You can use these device twins to send properties down to the device from the cloud, and you can also use them to connect, so check the parameters that the device is on. Say, for example, the firmware version of your devices. We can run a SQL-like query across our fleet of devices. We could pull back all the devices that are on a specific version, and then we could instruct those devices to update themselves. The device twins, these JSON documents, also have a concept of tagging devices. So this allows us to create cloud-only metadata about our devices, which the devices don't see, but it allows us to organize at scale. So, for example, having a customer tag or having a location tag, and then you can run those SQL queries on those tags as well. Oh, sorry. The device twins we can use to set desired properties. So that could be something like setting a status LED on a device, switching it on, switching it off, setting the alert threshold for a temperature device. When we set those desired properties, they get read by the device when they next connect. The device will then, using the code that you've put on the device, will execute, change its property, and then it will report back to the cloud to say that's completed, and that's then recorded in the device twin as well. We can also execute what's essentially a remote procedure call. So in Azure IoT, this is termed a direct method, and that requires our device to be connected to the hub at that moment in time. We get a result back in real time. So that sort of follows a request response pattern, and it's designed for where you need immediate confirmation that something has been executed, and you want immediate confirmation of the result. So for example, you may want to switch on a fan, and you need to know that fan's been switched on, so we can use a direct method for that. And again, back to security. So security perspective, it's an important point to note. It's always the device that initiates the connection to the cloud. So Azure IoT Hub never opens a connection from the cloud to the device. So there's never ever a requirement to open firewall ports inbound to your devices. There are 3 distinct protocols supported. So HTTPS, MQTT, and AMQP. So both of the last protocols I mentioned there, they're supported on their native ports, but they're also supported via WebSockets. Everything's secured by TLS, but when using one of those protocols over WebSockets, all of that communication goes over port 443. That's it's a common port that's open on corporate firewalls. So generally, I recommend going for either MQTT or AMQP over WebSockets. There are a number of different considerations that you need to think about when selecting the protocol. Probably too much for me to go into today, but those are really where I sort of direct customers to aim for WebSockets, and then that's you've got less chance of network disruption. Okay, last slide for a bit. So I'm going to go back to the demo I did at the start. So we've got the Percept device. We're still streaming telemetry back to Azure to be processed. So the diagram here is actually what I have set up in Azure. So the Percept's running a demo edge workload from Microsoft to identify objects. That video stream is never sent to the cloud. I've got a hot and cold path. So all of the telemetry is just going into a data lake, which could be used for archiving or batch processing or long-term analytics. Then also got a hot path. For the demo, I'm sending all of the data through to the hot path as well, but that goes into Event Hub, and then it goes into Stream Analytics jobs. So those Stream Analytics jobs are applying sort of real-time sort of computations on the data that's coming through. So I'm using them I'm changing a Unix timestamp into a human-readable timestamp. I'm extracting the fields that I want from the data. I'm also filtering out some of the data as well from there. The data is going into that Power BI data set to produce the basic dashboard that I showed. But then I've also got a second Event Hub and Stream Analytics job to produce those email alerts. So that's taking some of the data. It's then triggering a logic app to send an email out via SendGrid. So again, there's no virtual machines in any of this. It's all platform services. So a couple more slides to run through, and then we'll be on to some questions as well. Let me get this slide up, if it's going to work. There we go. Right. So the two more areas are Digital Twin and IoT Central. So while it's similarly named to Device Twin, Digital Twin is actually a separate IoT service, and this enables you to model an entire physical environment. So it really allows you to sort of model the relationship between people and spaces and devices, and you can correlate the data across the digital and physical worlds and create contextually aware solutions. So it's using a modeling language based on JSON again to create customized models of any connected environment, and we've got a couple of interfaces, a couple of ways of manipulating it. So we can visualize our data in Digital Twins Explorer, or we can query it with its powerful API. So when it's backed by additional resources in Azure, it can actually provide an up-to-date view of your sensors and environment because it's being fed the telemetry from Hub. So in the example on the slide, we've got a basic twin graph of a distribution center with 6 mechanical arms. So we can see the relationship between the assets, we can click on the arms, we can view properties and potentially the current telemetry that's coming through. So that visualization has come from the Digital Twin Explorer interface, which is the developer UI for managing that service. But for more powerful visualizations, Microsoft have got a service called 3D Scene Studio. It's currently in preview, but combining that with digital twins, you can create really quite flexible 3D representations of a business environment. So last area, I've mentioned IoT Central a few times. So in a nutshell, it's essentially Office 365 for IoT. It's a service Microsoft have developed in recent years to really dramatically simplify what's required to connect and monitor, and really to analyse and improve your devices and get you along your way to digital transformation. It's a set of ready-made capabilities. Microsoft are now terming it APaaS, or Application Platform as a Service, so it's like Experience, to allow you to build applications that connect to the devices and sort of manage them and find insights from them. It's what we would have called SaaS a couple of years ago. It's scalable, it's repeatable, and it's highly reliable. It really reduces the burden and the cost of developing and managing your enterprise-grade IoT solution. You can, if you go with IoT Central, you can invest more of your time in building your solution rather than maintaining and updating a complex set of IoT infrastructure. So its main interface is a web UI. We can use that to quickly connect to devices, monitor device conditions, create rules, and again, it's scalable. We can manage millions of devices through their life cycle. It provides really a really quick route to proof of concept and proof of value, and I think that's really it's where it can really is the perfect system to get started with. I generally recommend with customers starting out with Azure IoT Central and run with it as far as you can before considering building your own solution with IoT Hub, and really only use those platform services if you must. It's integrated with Azure plug-and-play devices, so you can get up and running with Central without writing a single line of code if you've got a plug-and-play compatible device. So Microsoft have a smartphone app in the various app stores. It's a plug-and-play smartphone app for IoT Central. Essentially, you scan a QR code in IoT Central, it connects your phone to it, and your phone will start sending telemetry such as its location, its battery level, gyroscope, things like that. IoT Central knows the capability of the app because the app broadcasts it, and you're up and running within a couple of minutes. So it is built on top of all the Azure capabilities that they've built up over the years. You know, it includes IoT Hub under the bonnet, it includes provisioning services under the bonnet, and key data offerings such as Stream Analytics that we looked at, Data Explorer, SQLDB, Cosmos DB. So when we deploy an IoT Central app, Microsoft stand up around 30 services under the bonnet, so they've done all the hard work of configuring them and deploying them. So we just need to come along and connect our devices and consume them. It's highly extendable, so it can export data to other Azure services such as Blob or Event Hub, and it has its own REST API as well, so that enables you to develop maybe a bespoke web client or perhaps a bespoke mobile app that will connect and integrate with your central applications for your customers to use. So you know, you can really build quite powerful applications on this. It provides multi-tenancy out of the box, so you can build up like a tree of different customers and maybe different departments under the customers. They have access to just the areas they should. When we deploy an app, we can go from a generic empty template, or we can go from an industry-focused template, and then we use device templates to connect the devices. So just one last thing before we look at it. In terms of billing, this one is billed per registered device. There are 3 tiers where the monthly message allowance per device increases through the tiers. It starts from 8 pence per device per month with 400 messages included, and that increases to 66 pence per device per month with 30,000 messages included. And then if you go over that limit, you're just charged overage. You're not, you know, your service doesn't stop. And you also get 2 free devices for the lifetime of the app as well. So you can actually get started with IoT Central for free. And that's it really. So I've covered the intelligent edge. You know, we've looked at the different hardware options and what it means to run workloads on the edge. I've reviewed cloud offerings from Microsoft Azure, key ones being Central and Hub. We've touched on security, and we've had a couple of demos as well. So this session's been a shorter version of a discovery workshop that I carry out with our clients. I hope it's given you all a flavour for what's possible with Azure IoT. I love sort of playing with this stuff, if I'm allowed to say the word playing. So things like the space station, and just really getting the data in and playing around with it, you know, I love it. But yeah, thank you everyone for taking the time to listen. And if you've got any questions, now's the time to ask. But if you'd rather ask them later, I'm here all day as well. So please call me later. Thank you.